Hello, everybody. It's wonderful to be here at Web Stories. And today I would like to talk to you about how the front end has changed. It's actually been changing without us really noticing for longer than you might think. But a big part of our front end now is no longer about pixels and color and layout and visual design, but it's about conversational design. And we're choosing our words and thinking about the way they sound and the way we say things as our new front end. So if you think about the title of this talk, Talking to Me, there are different ways that you could say that depending on how you wanted to sound, perhaps who you were. If I was Hercule Poirot, I might, for example, say, "You're talking to me, mon ami?" If I was Yoda, I might say, "Talking to me, you are." And then, of course, there's the original growling, rasping, "You talking to me?" from De Niro in the film that this quote. So we are thinking now about conversation as our front end. But as I said, we've actually been thinking about talking with technology for longer than you might think. We go back to the 1960s. IBM had a computer called Shoebox. That's one of the first examples of our efforts to talk with technology, and perhaps more importantly, to have technology do something sensible in response.
Last year, an experimental machine that recognizes the human voice was introduced to the press by its inventor, William C. Dersch, of the Advanced Systems Development Division.
Our efforts to communicate with, that is, control machines, have resulted in a demonstration voice recognition machine capable of operating an adding machine. Shoebox 2, the name given to it because of its small size, recognizes the 10 spoken digits and in addition 6 command words: 6, 7, 8, plus, 2, 3, 4, 5, 7, 8, minus, subtotal. The machine has understood my voice and caused the adding machine to correctly perform these arithmetical operations.
A machine that recognizes the human voice. Evidence of IBM's continued exploration into the technologies of tomorrow.
Now, time and technology have moved on since then, and the next thing that really started to make a difference in terms of the front end of voice interfaces was voice XML, a W3C technology that was created in the late 1990s, became a W3C standard for the first time in 2000. And as the name suggests, it's a variant of XML that enabled us to create structure to conversational interfaces. So the front end for voice XML interfaces became a voice browser. You'll most often have come across these in the form of the telephone menuing services that it seems almost every company in the world now prefers to offer instead of a human being on the end of the phone. But instead of having a conventional browser in the ways that we're used to, Chrome, Firefox, Safari, we, in this case, have a voice browser. And the XML structure looks remarkably familiar. We have, for example, a prompt element. Prompt, the thing that the technology will say to us to, well, prompt us for a response, is a very common theme in these voice interface architectures. So in this case, there's just simply a prompt element that is the way of marking up what it is we want the technology to say to the human being. There's also a menu element in voice XML that enables the technology to give the human a range of different options. You might often know these as the select one. What, unfortunately, this has led to is far too many services that give us experiences that sound a lot like this.
Hello. And welcome to hell. Please press 1 to make the wrong choice. Press 2 to listen to elevator music. Press 3 if you've lost the will. Or press 0 to hear these options again.
Because sadly, although the technology exists to create these things, the usability has often lacked a long way behind the technical capability. But all these things have the same thing in common. There is a basic architecture to a conversation, whether it's one human to another, or technology to technology, or technology to human. Somebody says something, they speak. Somebody else listens, they hear what's being said. They process what they've heard. They do something with that, and then they return a response that comes out usually in the form of speech. And that basic flow remains pretty unchanged when we translate from humans to technology. The technologies that we use to underpin that, though, are several different things. The first is automatic speech recognition. This is the thing that lets technology listen to what we're saying and translate that speech into text. As is often the case, text is really the kind of the most atomic level of information that these things deal with. Text is incredibly important. But this is just the start of the process. Apple have been working on automatic speech recognition for quite a long time, as have an awful lot of people, but they were one of the first to bring a product to market.
Macintosh, open letter. Macintosh, print letter. Macintosh, fax letter.
While everyone else is still trying to build a computer you can understand,
Macintosh, shut down.
we've built a Macintosh that can understand you.
Goodbye.
I'm still not actually convinced that any of us have got to the point where technology can really understand any of us, but I live in optimism. So what happens to that text? Well, there's natural language processing, and this is the piece of the process that takes the text, takes what someone has said effectively, and translates it into machine data. So puts it into a format and a structure that can be used for the processing, the thinking part of the process. That machine learning then is the bit that might respond to a query. It's, if you ask a technology perhaps to do some arithmetic, it's the bit that will do the calculation. It will look up, the general knowledge question you've asked, whatever it might be. This is the kind of the equivalent of the mental thought processes that a human has in a conversation. And then we reverse the process. Natural language generation takes the response from your machine learning processing and converts it back into text. We then have the last piece of the puzzle, which is text-to-speech. As the name suggests, this takes that text and converts it back into speech, completing the conversational loop. So we've had a complete round conversation. Someone said something, it's been taken, it's been responded to, and an answer has come back. Text-to-speech has been around for quite a long time as well. One of the earliest example, again, comes from the 60s, and this time in the form of an example from the Bell Laboratories.
Daisy, Daisy, give me your answer too. I'm crazy, all for the love of you.
And again, more recently, Amazon introduced the Echo. For any of you who have Alexa devices, this may now be a good time to turn them off. Things could get a little bit chaotic otherwise. But the Echo really took conversational interfaces in the home to the next level.
Introducing Amazon Echo.
Hi there.
And some of Echo's first customers. Echo is a device designed around your voice. Simply say Alexa and ask a question or give a command.
Alexa, how many tablespoons are in 3/4 cup?
3/4 cups is 12 tablespoons.
Echo is connected to Alexa, a cloud-based voice service, so it can help out with all sorts of useful information right when you need it.
To me, it's, bringing technology from Iron Man at Tony Stark's house into your own.
Echo can hear you from anywhere in the room, so it's always ready to help.
I can have the water running, I can be cooking, the TV can be on in the back room, and she still can hear me.
It can create shopping lists.
Alexa, add waffles to my shopping list.
Provide news.
From NPR News in Washington.
Control lights.
Alexa, turn on the lights.
We use it to set timers. We use that feature all the time, and that's one that's specifically helpful, I think, uniquely to blind people.
Calendars.
Today at 1 p.m. there's lunch with Madeline.
And much more.
So this now is one of the most popular front ends for conversational interfaces. So how do we build a conversational interface for an Echo device? Well, like the front end in the web, there are essentially two components to it. There's the interface, the bit that we interact with, and there's the service that lies behind it, the bit that provides the functionality and supports the interaction. The interface is built using an interaction schema. It's a JSON model, and it describes the conversational architecture. Quite simply, it's the invocation, the thing that you say to open up the skill, and then you can define things like intents and the other bits and pieces that go into the conversational architecture. An intent is the thing that, well, you intend to do. So when you are building an Alexa skill, you define one or more intents. These might be questions that you want to be able to ask the skill, or other activities that you want to be able to invoke by asking the device a question. There are a number of there are a number of default intents that Amazon provides for you automatically, so you absolutely have to have these in every skill that you build. They're just for basic things like being able to ask for help and being able to stop the skill or cancel it, because above all, in interactions with technology of any variety, you always need a kind of escape route just in case things don't go so well. They also make available a number of built-in intents. So these are things that are pre-programmed to make coding skills a little bit easier. So for example, you have intents that are ready-made for dealing with when someone says a yes or no. There's one for fallback. So if something that you say to the skill or to Alexa isn't understood, making sure that you handle that fallback gracefully. And these are very, very useful because they take a lot of the hard work out of the coding for you. So if we have a quick look at the schema for the help intent, you can see that if we were to create a skill that would let us ask about information for conferences that are taking place, you can see that the help intent has been defined. It's got Amazon as a prefix to the intent name. That's just a way of identifying the built-in intents that are available. And under the samples, you don't need to enter any speech samples in there because Amazon has already made it so that when you say to your skill or to Alexa, help, more information, or any of the typical ways we might ask for help, it already recognizes those. You don't need to specify them in your code. So it just makes that a little bit easier from a construction point of view. But if we were to define a custom intent, as we would need to do to make our skill properly useful, then we do actually have to start defining how someone would invoke an intent. So this one, we've got on screen a custom intent that will let us ask the skill for information about a particular conference. On screen, we've got a sample that says, tell me about web stories. Of course, we're here, why not? The difficulty about this is that you have to stop and think about every single way somebody could ask a question, and then you have to duplicate those samples for every single conference that you think somebody might want to ask about. And it turns out that humans ask very simple questions in an awful lot of ways. You could say, give me information about web stories, tell me about web stories, what is web stories, what's web stories, so you've got the contraction between what and is. Amazon estimated that a simple skill that lets you order a pizza where you have a choice of just one base, and maybe 5 or 6 toppings can result in thousands of conversational pathways. They have actually recently introduced a conversations API that uses more machine learning to take some of the pain out of coding for those, but that's a presentation for another time. One thing they have done, though, is made slots available. And this at least saves us from the trouble of having to write different speech samples for every single conference that we might want to ask the skill about. What we can do instead is define a slot called conference, and then where we write the samples, we just insert the word conference in curly braces instead of having to say web stories, inclusive design 24, and any other conference. So at least it removes that kind of repetition from it. So it reduces our need to provide speech samples down from, perhaps hundreds to perhaps just numbers of tens instead. So slots act a lot like placeholders, so they're a great convenience from the point of view of building skills. When it comes to actually putting the action behind the intent, so what happens when someone triggers one of the intents, it all starts with the core SDK. You can simply just pull this in with a single line of JavaScript. And again, credit to Amazon, they've done a great job at making it very easy from a development point of view. This pulls in a significant amount of the capability that you need to build most skills. We then have to decide what we're going to do once an intent has been triggered. And this is all about the request types. And there are 3 basic sorts. You have the request that comes in when someone opens the skill for the first time. You have request types that deal with intents, so any of the intents that you have defined in your interaction schema. And then what happens when the session ends for any reason, either unexpectedly or because the person controlling the device has instructed you or Alexa to close the skill. So launch request, again, it gets transmitted as a JSON request, and it contains a lot of different information. You'll have the locale of the device, the timestamp, and other information. And this gets sent out to say that someone has intended to launch the request. So they have opened the skill with the invocation name, in our case, conference info. You then have an intent handler in the code that you write. I prefer to write Alexa skills in JavaScript, Node.js. You can write them in JavaScript and other bits and pieces. It's entirely up to you, and there's a lot of templates and ready-made blueprints that you can use to accelerate this process as well. But if you look at the example that's on screen in the request handler for the launch request, you'll see some very familiar things. The idea of a prompt surfaces again. So this is the thing that Alexa will say when someone opens our conference info skill. She'll ask, what's the conference you want to know about? If the person doesn't respond after a number of seconds, Alexa will re-prompt you, give you a bit of a nudge to say, look, I didn't hear anything, here's the question again, and so you can define that. So again, starting that idea of initiating a conversation, prompting and re-prompting. And then in return, this gets sent out as another JSON request. And so the upshot of all of this is that we should be able to do something like this. Alexa, open conference info.
Hello. Which conference do you want to know about?
Tell me about Web Stories.
Web Stories is the web conference at the heart of Europe, created by 4 friends who are passionate about all things web. Hello everybody.
And from there, our conversation could continue. So that's the basic architecture of how a front-end interaction works for an Alexa skill. But there's something else on this screen that's particularly interesting, and that's the use of SSML. You can see it there just marking up the speech that Alexa invokes when you open the skill. Speech Synthesis Markup Language is another technology that's been around for quite a long time, this time in the early 2000s. And it is a way, as the name suggests, of letting us mark up synthetic speech. So again, familiar concepts to anyone used to front-end design and development on the web, but this time we're converting it into speech as an interface. Going back to Alexa, Alexa sounds very different depending on where in the world you and your Echo device are.
Hello, I'm Alexa, and this is how I sound in India.
This is how I sound in America.
And this is me in Canada.
Here I am in Australia.
And this is me in the United Kingdom.
So that's Alexa in her default voice in different accents for different parts of the English-speaking world. But that's just how she sounds, a very nice, gentle, pleasant sounding, slightly happy, upbeat kind of a voice. And that's most often, of course, how you will experience Alexa. But you can actually use SSML to change the way Alexa sounds. SSML is a markup language, and so it has, again, some very familiar concepts. There is a paragraph, a P tag, for indicating when something is a paragraph, and consequently that it should have a bit of a pause at the end when you reach the end of the paragraph, the full stop. So if we play this example in Alexa's own voice, it sounds like this.
The terror, which would not end for another 28 years, if it ever did end, began, so far as I know or can tell, with a boat made from a sheet of newspaper floating down a gutter swollen with rain.
Now, there's nothing absolutely at all wrong with that until you realize that those words are the opening sentence or so from Stephen King's It. To my mind, at least, one of the most terrifying books I have probably ever read. The narrator of the book is a person of middle age. They're American, they're male, and so Alexa's voice does not sound at all appropriate. Good news is SSML lets us change that. There is a voice element, so we could change the gender of Alexa to be more fitting to what's being spoken. In this case, we're using a voice called Matthew to do that. So that's one step in the right characterization. We can also use the emphasis element. This lets us just place greater or lesser emphasis on certain words in the passage of text. So we can place more emphasis, for example, on the word terror, just to give it greater prominence in the way it is pronounced.
The terror, which would not end for another 28 years, if it ever did end, began, so far as I know or can tell, with a boat made from a sheet of newspaper floating down a gutter swollen with rain.
So it sounds much more in tune with the character we would expect given the content. So I guess the equivalent of our visual design being sympathetic to the content, this is our voice design being sympathetic to the content too. But there's an interesting thing going on here. If you listen again to that example, pay particular attention to the way the word years is pronounced.
The terror, which would not end for another 28 years.
It comes out sounding as years, so it's not quite American. Actually, as it happens, the book It is set in New England, and that is not a million miles away from a New England accent for pronouncing the word years. But in this case, I can't admit to it being intentional. It's a product of the fact that my Echo device is registered in the UK. And although I've coded this skill to use an American voice, I haven't done anything to really change its pronunciation, and the two are somewhat separate. We can change this too by using the lang element in SSML and telling it quite specifically not only to use one of the American voices, but to use the language code for America as well. And this, if you listen again, changes the way that one word is pronounced just a little bit to a more American sounding pronunciation.
The terror, which would not end for another 28 years.
So there are two parts to accent and pronunciation, the voice that you use and the origin of where that voice comes from, and also the language for the pronunciation. Let's take another example, this time a quote from a film I'm sure will be known to many of you.
Hello, my name is Inigo Montoya. You killed my father. Prepare to die.
Now that, you'll have to agree, I think, sounds entirely wrong. Just all sorts of wrong about that. Doesn't sound at all right. But again, we can do something about that. We can use the voice element again, this time to choose a Spanish voice of the right gender. But we can also use the break element to introduce breaks in the flow of the speech. In other words, pauses that just, again, allow us to get the cadence of that quote more right, because for anyone who is familiar with that quote from The Princess Bride, it's the pauses in that sentence as much as anything that make it so iconic.
Hello. My name is Inigo Montoya. You killed my father. Prepare to die.
Much better and much more, again, sympathetic with the content in question. There's also an S element, this time for dividing up sentences, so a smaller kind of block than a paragraph, obviously. And we've got another example, this time from Winnie the Pooh.
Piglet sidled up to Pooh from behind. Pooh, he whispered. Yes, Piglet. Nothing, said Piglet, taking Pooh's paw. I just wanted to be sure of you.
Now, arguably, that's not too far away from being the right kind of voice design for the content. But the Winnie the Pooh books are read, or they are the memories, if you like, of Christopher Robin. So again, the gender is perhaps not quite right. But more importantly, we can use the prosody element to enable the narration of this text to take on a slightly different characterization for the things that Piglet says. If you're familiar with these stories, Piglet is small, a little bit squeaky, and so as we're listening to this content, we want that to be reflected in the characterization. Prosody is the linguistics term for the kind of characteristics of a voice, if you like, the rate at which someone speaks, the pitch that they speak at, and a number of other characteristics, volume, for example. So using the prosody element in SSML, we can tweak the way Piglet is presented in this text.
Piglet sidled up to Pooh from behind. Pooh, he whispered. Yes, Piglet. Nothing, said Piglet, taking Pooh's paw. I just wanted to be sure of you.
So again, we can make it just a little bit more entertaining and, in this case, perhaps amusing. And this is all done through an Alexa skill. This is all things that you can do to make an Echo skill just a little bit different sounding, more entertaining, more appealing, more distinctive, give a brand identity, for example. Amazon makes available a number of other things that you can use as well. There is an ability to enable Alexa to whisper back to you.
Shh, be very, very quiet.
And actually, default behavior, if you whisper to your Echo device, she'll whisper back to you. But you can also deploy this in your skills if you want. Although, if anybody put that in a skill, I have to say I would probably be hiding under the couch quicker than you could blink. But maybe that's just me. There's another one, another example. If we wanted to inject some emotion into what was being said, this is Alexa saying what's on screen in her default voice.
I'm so excited, and I just can't hide it.
So not terribly excitable sounding, really, but you can use a proprietary SSML element that Amazon has provided for emotion with an attribute value of excited.
I'm so excited, and I just can't hide it.
And I had to do that in the American locale because it just sounds so much better with an American accent. But you could also flip it around and use the disappointed attribute to make it sound very different again.
I'm so excited, and I just can't hide it.
It's said with all the British sense of humor there, I think. So yeah, injecting a little bit of emotion into what's being said. There are also specific voice types, voice characters that are available. One of the better ones is a news broadcaster voice. So you can just use this and the voice characteristics are pre-programmed in.
Now it's me, with the news. Today absolutely nothing happened. Everybody went and had a nice cup of tea instead.
So just using that one element and the news attribute, Alexa takes on a slightly newscastery tone of voice. There are also some more entertaining ones that you can have. There's a say as element in SSML, and if you use the interpret as expletive, you can get Alexa to beep out content that might be offensive to certain audiences. Or, in the case of this example on screen, you can actually imply that what's being said is an awful lot worse than it actually is.
Frankly, my dear, I don't give a...
So, yes, you can use these things in a variety of different ways to kind of invoke different reactions in your audience. One of my favorite is that there are a number of things that Amazon has introduced called speech cons. For each of the supported languages on Echo devices, they've come up with over 100 different very short words and phrases. They are very nationally stereotypical, but they've pre-programmed them so that you can use them very easily, and they come out sounding quite distinctive. Here is the British English set, for example.
Ace. As if. Bar humbug. Blimey. Cha-ching. Crikey. Eek. Good grief. Hiss. Moo. Nom nom. Oof. Oi. Simples. Tick tick tick. Uh-huh. Wee.
So instead of having to use elements like prosody and break or emphasis, these are just sort of ready-made speech cons for you. Here's another example. I'll give you the Australian ones as well, or a sample of them, because I love these. I think they're great.
As if. Aussie, Aussie, Aussie. Oh man. Blimey. Bummer. Checkmate. Fair dinkum. Fair go. G'day. Good on ya. No worries. Struth. You beauty.
So lots of different things that you can use. And with Alexa skills, and indeed Google Home, all of these technologies still apply. There is so much more that we could be doing to make our voice interfaces more entertaining, more engaging, and more appealing. But of course, Home Assistant devices are not the end of the story. We are seeing more work happening into speech interaction in conventional web applications. A lot of work is going into a set of technologies called the Web Speech API, for example. They've been around for a little while. There's a W3C community report, but there's increased interest in them again, and I'm optimistic that at some point we might even see these become official W3C standards again. The Web Speech API is a JavaScript API that has two interfaces, Web Speech Recognition and Speech Synthesis. Speech recognition, as the name suggests, it's the automatic speech recognition part that we were talking about earlier. It will listen to what someone is saying and convert it into text and do something with it for the web application. Speech synthesis, conversely, is the bit that we can use to have the application speak back to us. And that's the bit I'm just going to focus briefly on now. So you have a speech synthesis utterance. This is the object that really handles all the speech synthesis and the associated functionality. We have the utterance itself, the thing you want the application to say back to you. In this case, I've just chosen tequila. Of course, this is me we're talking about. Why wouldn't I? You then have a speak method, and you simply just apply that method to the speech synthesis object and instruct it to say whatever you defined as the utterance. You can also get voices. So when you use the Web Speech API, it will use whatever text-to-speech engines are available on your platform and for the browser in question. Every common platform these days, Windows, Linux, macOS, iOS, Android, all have a collection of text-to-speech engines available, and within different browsers you may get additional ones. Chrome, for example, has a huge choice of text-to-speech engines covering different regional accents, different languages, and different genders. So you can get an array of these using getVoices, and that then enables you to choose the one that you think is the right choice for your content, and to assign that using the voice attribute. So in this case here, I've just grabbed the Hazel voice, which is available on Windows 10. It's the female British voice, because at the time I was writing these examples, that seemed like the best choice at the time. So here's a quick example of how we could use the Web Speech API speech synthesis interface in a browser application. When I first coded up this quick demo, it was actually before browsers had started making it possible for you to actually listen to content in the browser, but it basically utilizes that same idea.
News headline, nothing happened, reported on the 1st of April. Nothing happened today. Everybody went and had a cup of tea instead.
So it's very easy to build in the ability for a web application to speak back to you and, of course, to listen to what you're saying too. There's also another technology that sadly does not have good interoperability or barely any interoperability at all, but I remain very hopeful that one day we will get support into browsers and other technologies. CSS Speech, it's a module that's actually been around for a long time. It started off as oral style sheets back in the early 2000s. It's currently the CSS Speech module. And like conventional CSS, it gives us the capability to design the interface, not visually as CSS usually does, but in terms of synthetic speech. So this is kind of the separation idea that we saw. If you think of SSML as being like HTML was perhaps 15 or 20 years ago, when we still had things like font tags and center tags and other things that put the visual presentation into the HTML markup, SSML is sort of the same. We have kind of presentational markup in the form of structural markup. CSS Speech would give us a way to separate those two concerns as we did on the web front end. And it will have a lot of very familiar characteristics. There's a speech property, and if it was supported, what this would do is act very much like display property does visually. You can set it to auto, and that will actually set it to mirror the display property. Or you can set it so that, yes, anything that has this attribute applied to it should be spoken by your synthetic speech or should not be spoken. So the auto is nice because if you have content that's set to display hidden visually, then it automatically will assume you don't want that to be spoken either. So you've also got things like voice volume suggests you could set the volume of it. And this is one of the concerns with implementing support. People who are browser implementers have expressed concern about this, particularly people who are involved in the usability of such things. There's a worry that by having control over the design of volume and other characteristics, we could create interfaces that were impossible to use, particularly if screen readers implemented support for this. It could potentially make the experience of interacting with content impossible for blind people to use. But the spec itself recommends that these things are relative. So if you increase the volume by, let's say, 10%, it increases it only by 10% relative to the current volume of your system. And what you can't do with these systems is go for dramatic increases in any direction. So you can't suddenly scare the hell out of someone by increasing the volume to an uncomfortable or ridiculous degree. So there are sort of parameters built into the potential implementations. You can change the rate of the voice, again, speed it up or slow it down to give it different texture. You can change the pitch, make it higher or lower compared to the default of the text-to-speech. And you can bring all these things together to just make the audio experience, the speech interface experience, much more interesting. And the reason I'm so hopeful that this technology will one day gain some support is because I'm a screen reader user. And if you have ever heard a screen reader, you will know that they sound exactly the same no matter what they're talking about. It doesn't matter if I am just reading about, a riot, a hurricane, a kitten being rescued from up a tree, whether I'm reading my email, the agenda for a meeting, my screen reader sounds exactly the damn same, and stuff gets boring. So a news item gets read like this.
News headline, nothing happened, reported on April 1st. Nothing happened today. Everybody went and had a nice cup of tea instead.
It's kind of the equivalent of every website you look at being monochrome. Absolutely nothing, no color design, possibly not even any changes in layout or structure or visual prominence or nothing. It will be tedious beyond belief, and that's actually a lot like what the audio experience is for a screen reader user. But if we could get browsers to implement support for CSS Speech, we could then get the text-to-speech engines and screen readers to do it. We could use CSS Speech to lift up the audio conversational experience of exactly the same content. Again, these tweaks are subtle, but they do make a difference.
Heading level 2. News headline, nothing happened. Reported on April 1st. Nothing happened today. Everybody went and had a nice cup of tea instead.
So that used all of those things. The pitch got increased for the date because you just need to snap that out. The volume got raised just fractionally for the news headline to give it kind of greater prominence. And again, none of these are extreme measures. They're just gentle changes to the way the screen reader pronounces the content that enable the listening experience to be that much more engaging. This actually was a proof of concept developed using the Web Speech API because, as I say, there's no real support for CSS Speech at the moment, but I do remain optimistic. So that, I hope, has been some useful and perhaps a little entertaining information on how our front end looks now, or more to the point, how it listens now, and how we can do things to make the experience even more engaging than the default options that we so often tend to stick to today. I hope it's been interesting. I hope you've got some questions, but if not, thank you and goodbye.
Goodbye.